Why do we need something like virtualization? We said about abstraction, consolidation and optimization, and sharing on top of abstraction, right? So it's primarily when there is so much of traffic. Yeah, I mean, so much of traffic in the sense there is way too many people trying to access something. We have a resource sharing problem. Right? We have a lot of vehicles that share a single common road, isn't it? So when we have a lot of practical difficulties in understanding, using a shared resource, that's where something like virtualization comes into place. So virtualization, the primary idea behind virtualization, so abstraction by definition, in terms of usage, sharing becomes the most important part. I think Sashi will have to give a lot of importance to this because you don't have an infrastructure background. Okay, so primary idea about virtualization is that what it does end of the day is that it shares. Okay, it allows sharing. So it is equal to how you do carpooling. So you can have multiple people sitting in a car. So something like that. So what virtualization ends up doing, something that we try to achieve with cloud and virtualization. You guys talked about, yeah, you are the one, Sashi is the one who said about this, right? Wanting to elastic load balancing. So one of the ideas is that you need to make sure that you use maximum utilization of resources in a given way. You need to do more with what you have or more with less. Okay. So what virtualization does is that maximum resource utilization. You'll have to, push in as many people as possible in a single way. Virtualization does more with the same, right? And this is one simple game that fits into IT infrastructure problem than anything else. If you see it, the less amount of free space that you have in between, more that you can actually do, isn't it? So this is very similar to what we have, and this is very critical for you to understand cloud-based infrastructure as a service also, because in a three-dimensional view, you can fill in the space anytime, right? That's how cloud resource scheduling algorithms work. So what virtualization eventually does is that it does more with less, okay, or it does more with less. This is another important or slide that's closest to me. What does virtualization do? It's there in the kitchen. You have a lot of different jars with half full, half empty content. And when you do virtualization, it comes to something like this. So when we talk about virtualization, this is something that I was actually expecting. Now the idea is that when you see the picture, I wanted you to possibly think of containers. That he came up with that. So container is a word apart from your standardization, optimization, and everything else. So container is very, very critical point. So what we have is that multiple individual containers are put in a single container. So we consolidate things, we optimize the resource, and these containers are very clearly separated so they coexist. Okay, so that's the keyword that I was expecting. That is very important for you to understand at a later point in time to how well we optimize and utilize resources. So what we actually have is that we have multiple individual containers or multiple individual hardware pieces which have their own operating systems plus applications, and post surgery they become one single hardware. Multiple what we call as guest operating systems. We'll have a hypervisor layer. Okay, do you know from where this word hypervisor comes? Operating system is called a supervisor. Okay, so a layer that sits on top of the operating system, or the layer that supersedes the operating system, layer that can control and supervise the operating system, the layer that can supervise the supervisor becomes a hypervisor. Anything on top of super is hyper, right? So that is why the word hypervisor comes in. So hypervisor is responsible for anything that runs on top of the hardware. So remember, in the traditional way of or a non-theoretical way to look at cloud computing is also a management layer on top of a virtualized infrastructure. But theoretically, it is not necessary to have virtualization to have cloud. We'll discuss more on that as we move on. Okay, you can actually have physical servers and physical components provisioned to cloud. But just to have an understanding, hypervisor is the most critical layer here, and that is, as one of you said, is a software layer that provisions hardware and storage and whatnot on top of it. Okay, so you have a physical resource, you have a hypervisor layer that abstracts that physical resource to start with. Okay, we are taking a server virtualization example here, but the same for desktop virtualization, network virtualization, or storage virtualization as well. Okay, there is no major difference from there. So you have a hypervisor layer that abstracts these. It standardizes any hardware or any operating system that runs on top of it. It consolidates and optimizes the resource utilization on top of it. And individually, what it creates is that it creates multiple containers that share one single large container. Generally, through the hypervisor, you do this orchestration. So this is the guy who actually does manage the whole music show. He says, you guys move here, this and that. But if you look at it in a cloud environment or a slightly complex virtual environment, it is not the hypervisor that orchestrates. Hypervisor is a musician, and you have a centralized management system that orchestrates even the hypervisor. If you look at from a VMware perspective, your VMware vCenter kind of a component will have the orchestrator, which will move the virtual machines in and around, which will tell that this is what should be doing at a given point in time. So this is how it looks. You have individual containers with individual servers or desktops or whatnot with operating systems and application on top of it. And post virtualization, you have a new layer introduced in here, which is a hypervisor layer. You look at there's a green layer here in which multiple application operating systems are put in. Now, this is an important component that you should understand is that post virtualization, one of the major takeaways for us is that you have a layer that separates application from and operating system combination from the underlying hardware. It's very clearly separated, right? So there's a hardware component that is separated and all things logical on top of it is separated. Do you understand? So the application and operating system are now independent of the hardware that we have. So the point is that it is running so close or it is very tightly coupled with the hardware. In a virtualized system, in a virtualized environment, the operating system runs independent of the underlying physical hardware. That primarily means you can take the operating system and put it on another hypervisor, it will run. End of the day, a virtual machine is nothing but a set of files. So like you can carry files on different machines, between different machines you can migrate and do stuff. You can carry an operating system. Similarly, can you separate your application from this? You have a, say, PowerPoint application, okay? You have a Microsoft Office installed in your machine. So the point that we are trying to create right now is that the application and operating system, which is logical in nature, is separated from the physical component. That's where the key abstraction lies. There is a hiding. The underlying physical hardware is hidden through the application and operating system combination. And this hiding happens through the hypervisor. That is very, very important. That's the abstraction that you are talking about. So you create logical spaces on top of which the application operating system runs. And as I said, that gives you the ability to move around the application operating system component, or as we call it, it's an appliance.